Ladies and gentlemen, CFrames can be really hard for beginners to understand. Well, I have 5 years of experience with scripting in Roblox, but I just started to understand CFrames. But the thing is, they're really simple. However, I found out that they're really hard to explain. In fact, I re-recorded this video like a lot of times, and I hope this is the time that I'm gonna upload this video. Alright. Anyway, so let's begin. I'm gonna try my best here to just give you a basic understanding and intuition of what is a CFrame and what you can use it for. Alright, let's make first of all a part. Alright, you can see this part right here. Let me do something. Let's start right click and let's just show up the show orientation indicator. Now this is where the part looks at. Alright, and if you go to the view tab, you can find the view selector here. Just click it and you're gonna get this little cube right here. Okay, now the thing is that you should understand before trying to understand CFrames is that how we can describe the location and the rotation of an object in space. The thing is, you always need a reference. Alright, so the reference of the world space. So there is two main spaces in Roblox. There is the world space, which is this one right here, XYZ, like this, and there is object space. For example, the object space of this guy right here is this arrows. This is the z-axis, this is the x-axis, and this is the y-axis. However, the world space, y-axis, z-axis, x-axis, are this ones right here. Okay, so as you can see that the world space axis doesn't change. Doesn't matter where you are in the game or whatever, they don't change. The y-axis in world space will always look up. Alright, the y-axis in, like the negative y-axis in the world space, will always look down. X will always like be in that way, Z will always be in that way, etc, etc. However, when it comes to object space, that way of describing location, let me show you what's gonna happen here. So if I like used my move tool, as you can see that in the local space, this is the local space, so the y-axis of the object space is following the rotation of the objects. As you can see, is relative to the position of the offset the objects and its rotation. Alright, let me show you what is world space. If you do Control L, it's gonna give you the world space. So as you can see, it will always look up like this and like this and like this. Now if I pressed again Control L, I'm gonna switch up to object space. There we go. It's really important to understand what is the difference between object space and world space. World space, basically we have an arbitrary center, an arbitrary rotation, etc, etc. But in object space, our coordinates are linked, are relative to a specific object. Alright, as you can see here. And again, if you press Control L, you can switch between object space and world space. This is world space and this is local space. Alright, so I emphasize this point because it's the most thing that you should understand. If you understand this, then you basically understood most of CFrames, you know. Alright, and there's also the rotate, as you can see here. Control L, Control L. Again, this is the world space, as you can see here. So it doesn't matter like what's the rotation, like what's the current rotation and position of the objects. All that matters is the world space. But if I switched back to object space using Control L, you can see that the situation have changed. You can see that this yellow circle, which is the y-axis of rotation, you can see that it's relative to the part's rotation. As you can see, it follows it. Look at that, you see. Now the thing is, let's say we have a part. Okay, there we go, we have a part. Let's first see where this part is going. show orientation indicator, and there we go. This is the front of the part. Okay, so in the object space, the minus or the negative z-axis will always look in the front, from the front face of the object. Okay, cool. Now let's put a script here. Alright, now the thing is, we want to move this object forward. So what we can do? Well, we can use just vector 3s. Let's pretend that we don't know like CFrames for now. We're just going to use simple vector 3s, okay? Alright, so script, let's say local part equal to script.parent, basically the parent of our script right here, which is our part. Basically here we're taking a reference to the part. Alright, so now let's just, we need a way to repeat an action, and whenever I say repeat an action, you should go to a while loop or using run service. And to just keep this simple, I'm just going to use a simple while loop, okay? While task.wait, do something. That's it. Alright, now what I can do is part.position equal to part.position plus something. Because what is part.position? It's just a vector 3. And what is a vector 3? It's just like 3 numbers that describe the location of the objects in world space. Alright, world space. I emphasize it again. So now I need to figure out what I need to put in my vector 3. So I want this object to move forward, which is in this direction. So as you can see in this axis right here, so this is positive z and this is minus z. So what I should do is plus vector 3, 0 in the x-axis, 0 in the y-axis, and z I should say minus 1. Why? Because I don't want to move in the x-axis and I don't want to move in the y-axis, which is up and down, but I do want to move in the z-axis. And which direction or which sense? I don't want to go like in the positive z-axis because that will be the back of the part, but I want to go in the front, so I should get the negative z-axis. That's why I said here minus 1. Now let's try to run this and see if that works. Alright, so let's see our output and let's see what's going on here. Attempt to call table value y. Let's see. Oh yeah, I forgot about .new, which is the constructor of a vector 3. And there we go. As you can see, our object moves. Now the thing is, if we change the rotation of this part, remember our goal is to move the object with its front face, you know, like just move directly relative to the object. So let's see what happens here. As you can see, it doesn't do that. Why? Because we're using world space, because we're using vector 3.new. Alright, now how we can achieve that using CFrames? It's pretty basic. Instead of position, you're just gonna say CFrame. Instead of position here, you're gonna say CFrame. Now the thing is, if you just stopped here, it will be perfectly the same. As you can see, pretty much it's still in world space, because if you added into a CFrame a vector 3, you're just doing a world an operation in the world, you know, like space. But we want to do the operation in object space. How we can do that? Well, I'm gonna remove this, or actually I'm just gonna comment it out so you can see it, so you can see the difference that I'm gonna do. Now instead of vector 3.new, I'm gonna use CFrame.new. Okay, there we go. As you can see, I didn't change much. I only changed from vector 3 to CFrame. Alright, let's try and see what's going on here. As you can see, invalid argument 2, vector 3 expected CFrame. Now the thing is, there is nothing called like adding a CFrame with another CFrame. That's not a thing. But you can multiply CFrames. Why? Because CFrames are mathematical matrices. Have you ever heard of a matrix? A matrix is really useful when it comes to describing object space, world space, and like transforming from, like, let's say you are in world space and you want to go and do something in the object space, etc., etc. Basically, matrices or a matrix can take a position in some space to another space. Well, anyone can create a new space and anyone can create a new matrix that does something with a vector, but that's out of the scope of this video. Anyway, now let's try this. So as you can see, I just converted plus to multiply. Let's see what's gonna happen here. Well, it worked perfectly. As you can see, it's going in the, and since let me do something. I need the command bar. I'm just gonna say workspace part dot front surface equal to enum dot surface type dot hinge. As you can see, we got this hinge in the front surface, and let me test again. And as you can see, it's going in the front surface, and if I rotated this thing, oh god, I can't really, let's make it a bit slower, minus 0.01 for example, run, there we go. Alright, so as you can see, it's going in the right direction, and if I rotate it, oh wait, it should be anchored, and if I rotate it, as you can see, it's still moving in to the front surface because we're using object space using CFrames. Basically, it's using this axis, not this axis, which is world space. You see what's going on here? And I can rotate it however I want. There we go. As you can see, it works perfectly. Let's redo it again. One more time. Let's get the rotate tool, and you can do this. You see how cool our CFrames and so simple? So basically what we're doing here is we're taking the original location of our part and we're offsetting it, or we're adding to it this vector, but in object space, not world space, so relative to the rotation of the part, if you will. Alright, cool stuff. What if I want to go in like the back face of the part, and I'm just gonna say this. As you can see, what if I want to go to the right of the part? I can say 0.1, let's say, in the x-axis. Now as you can see, my part is going to the right direction relative to it. If I say minus, then it's gonna go to the left direction. Isn't that so cool? So as you can see the difference here. Let's say I have a map, right? And you can give me a coordinates of the treasure, right? So for example, this is the treasure, right? And this is me, right? So I want to go to the treasure. How I can do? There is two things. You can either tell me to like the location in XYZ in the world space, and I can figure out and get to it, like maybe let's say I can wait, let's say 45 degrees or something. This is the orientation, let's say 0. Alright, so what I can do is go through the x-axis, or actually, yeah, negative x-axis, and then I can rotate and go to the z-axis, positive z-axis, until I reach my target. Okay, this is world axis or world space. Okay, now let's say you're gonna tell me the location of the treasure in my object space. How are you gonna do that? Well, you can tell me to rotate, for example, 45 degrees relative to where I'm looking right now. I'm gonna do that, as you can see, and then you can tell me how much I can move forward. Now we're talking about object space, not world space. So I hope this was pretty useful to you. So if you run here, as you can, well, not the right, you should go forward, bro. Forward, minus 0.1, run. And as you can see, it goes forward and it will reach my thing. So as you can see, the difference between world space and object space. And CFrames are basically mathematical matrices. When you multiply a matrix by another matrix, it's like you're offsetting or you're transforming something, but whatever. Well, now the thing is, right now we're moving relative to our own rotation and our own location. Now let's say we want to do that in the world space. What we can do is create, instead of saying part.cframe, which is our current CFrame, what we can say is CFrame.new. So we're going to create a new identity CFrame, which is basically a blank identity. Now let's try that out. So where's our part? I guess that's it. No? Wait. Let's remove this one. Alright, let's see where this goes. Okay. Part, there we go. As you can see, it's in the center of the world. So we're using world space right now, because a blank CFrame is basically world space. Alright? Let's say, for example, 10 in the z-axis. 10 pixels, not pixels. 10 units in the z-axis, and as you can see, it did that in the world space. But if I want the object space, then I should say part.cframe. Alright, now let's say I want to rotate this part 45 degrees relative to my own rotation currently. So I want to rotate it 45 degrees more, something like this. Okay, so how I can do it? So I can say part.cframe times, instead of .new, I can say .angles. Alright, times CFrame.angles. So 0, this is the XYZ. So this is X. You can see like up and down is X relative to the object. You know, like turn left and right is Y-axis, and turn like tilt is the Z-axis in object space. Okay, cool. CFrame.angles. So you should give it the X, Y, and Z, but in radians. Alright, so you should say math.rad 45 degrees. However, we don't want to do that in the x-axis. We want to turn around, so we're gonna do it in the y-axis like this, and then the z-axis we're just gonna leave it as 0. And maybe I'm gonna turn 1 degree every time. Let's run, and there we go. As you can see, right now we're turning in the y-axis by 1 degree every whatever that is. And to make this better, let's use run service, because run service is much better and the one to go with this. Game get service, run service. As you can see, I'm really going slow with this tutorial because I'm trying my best to explain it slowly and not, you know, overrun everything. Alright, because CFrames can be really hard for beginners, and I really feel it. So run service.heartbeat connect function, and our heartbeat event gives us something called delta time. So this heartbeat function runs typically 30 times per second, and every time it runs, it gives you the amount of time that have passed since the last time we run this function again. Okay, whatever. Alright, I don't need this anymore. Now what I can do is, instead of math.rad1, so I can use delta time. This will mean that we're gonna turn 1 degree every second. As you can see, it's only 1 degree every second. If we want to do full turn every second, we're gonna say times delta time times 360, and there we go. It's 1 turn per second, because every second we're turning 360 degrees, right? And I'm multiplying by delta time because you should notice that this thing will run 30 times per second, possibly. So that's why delta time is quite a little number, but whatever. We can just go ahead and turn 180 degrees, as you can see, and we can also move forward. Now there is two things that, there is something that you should understand here, is that the order of CFraming matters. All right, so if you say CFrame.angles first, then times, then you're doing it all wrong. You won't get the thing that you want, as you can see. Look at that. What's happening here is that it's turning around the center of the globe. Why? Simply because CFrame.angles doesn't have a position, okay? So what you're telling it is that you want to rotate, and part.CFrame is the offset of the part, or the object space of the part, relative to the world space. So in this case, it's relative to the center of the world, etc. So when you say first CFrame.angles, you're telling me that you want to, from the world space, take some angle. Then what you do is you add to it the offset of the part. So you're rotating first, then you're offsetting it by the part's location, rotation, etc. Which means that the part, instead of rotating about itself, it will rotate about the world space, about the world center. So as you can see, that actually CFrame order really matters here. Alright, let's go back to the old one so you can see it again, hopefully. As you can see right now, again, it's rotating around itself, because what we're doing first, we're taking the offset of our parts from the world space. So that's basically, we're going into object space, and then we're offsetting our object space by some angle. And that's why this thing rotates. Cool stuff. So this is the y-axis, x-axis, and z-axis. Remember that the x-axis is actually, of course, in the object space. I'm talking about object space right now. Please remember that, okay? So the x-axis in object space of a rotation, it tilts the object up and down. All right, it's like your this is your head, okay, and then you're tilting up and down. That's the x-axis. And if you see, if I take this, I put 0 here in the y-axis, and the x-axis that I said about, I'm gonna put that there. As you can see, it rotates like that. Alright, for the y-axis, it's turning sideways. Okay, as you can see here, it's turning sideways, like right to left, etc., etc. It's like you're turning. Okay. For the z-axis, you're tilting your head. All right, like a motor. Okay. So the front surface always looks in one direction, but the other stuff turns around. So as you can see, that's really cool stuff. Alright, let me think about something else. Alright, let's see. I think that should be it maybe for today. Let me think a bit and I'm gonna get back. Alright, so you should also understand the fact that we can also stack up angles. So if I do something like, let's say, this, I multiply it again. So as you can see, I just took this angle and I multiply it again by another angle. What this will do is that it will rotate this angles plus this angles. Alright? But you should be careful about something. This is really something really important to know. Is that rotating, for example, in the x-axis first, and then rotating in the y-axis first, is really quite different. So rotating the x-axis first, then the z-axis, is quite different from rotating in the z-axis and then the x-axis. Let me show you how. So you see this part right here? I'm just gonna rotate it like this, and I'm just gonna show you what's happening here. I'm just gonna make a clone of it, alright? It's the same copy, alright? So they have a similar object space in terms of rotation, but yeah. Anyway, so I have two scripts right now. One script, I'll make it rotate in the x-axis first, then the z-axis, and in the other script, I'm gonna make it rotate the other way around. I'm just gonna like invert the order of this. And let's see what's gonna happen. As you can see, they're rotating really differently, because one of them is rotating in the x-axis first, then the z-axis, and the other is rotating in the z-axis first, then the x-axis. It's just something that you should look out for. It's really important, right? Cool. Now let's say that we want to take this part and rotate it around this part right here. How we can do that though? Okay, size, let's say for example 1, okay, and then we have this part. So I'm just gonna remove the script inside here, because it won't rotate or anything basically. Or actually, let's leave it. Okay, let's leave it. Let's leave it. But for now, we're not gonna do anything about that. We're not gonna change its CFrame or anything. We're just gonna control this guy. So here's what I'm gonna do. I'm gonna call one A, or let's actually call this, let's just leave it as part, but this one, call it center. Alright, now here, let's get the center though. Local center equal to workspace dot center. Alright, so let's remove this stuff. Let's go ahead and let's say, so instead of part.cframe, I'm gonna start by the center.cframe. Center.cframe, okay? Times object.cframe, or in this case part.cframe. Alright, let's see what's gonna happen here first. Alright, this is crazy now. Let's go with the CFrame.angles, for example. Let's say, for example, maybe 10, or delta time. Let's see what's gonna happen here for a sec. Oh, what the hell? Oh yeah, 0, comma, 0. Let's see what's gonna happen here real quick. Well, as you can see here, that it just like go ahead and do it there. Alright, let's figure this out. Alright, gotcha. Maybe part.cframe, no, wait, what the heck I'm talking about? Let's see CFrame.new, okay, 0, 0, 1, or let's go with 10. So now basically what I'm doing here, let's do -10, okay, in the z-axis, is that this part right here will always be 10 studs ahead of this part. So when I rotate it, it rotates with it. It's like an axe. You're holding an axe. As you can see, it will always be 10 studs in front of it, because what I did is that I I got my part.cframe equal to center.cframe. So my center.cframe times 10 studs in the minus or negative z-axis, which is the front axis. So minus 10. And as you can see, this is what I got. It will always be 10 studs in the front of the part. Alright, now let's say I want to, let's rotate the center, dude. Let's do that. Alright, times, let's remove this stuff. So part.cframe times cframe.angles, 0 here, and I want to turn it around, so in the y-axis 180 degrees per second, and as you can see, it works flawlessly. Perfect. Maybe I want to change like the the offset. So how I can do that? Well, here, I should do it here. Let me use, let's say, minus 10. Let's say minus math.sine of, well, t, which is basically time. Local t equal to 0 at first, and then t will accumulate how much seconds have passed. Basically, t will hold how much seconds have passed since the game started, or since the script started. Alright, so minus 10 minus math.sine of t, or time. I'm just gonna say times 5 studs, for example, so there will be a change of 5 studs. Let's run. Alright, it's doing it. However, I'm not sure if you're noticing it. But I'll make you notice it. Okay, let me see. So I'm gonna make a trail. Right? I'm gonna make an attachment. Where is an attachment though? Attachment. Oh yeah, there we go. Attachment. There we go. Alright, I'm gonna put an attachment here maybe, and here maybe. Alright, I'm just gonna create a trail. There we go. I'm gonna set the attachment 0 to one of them, and the other attachment, there we go. I'm gonna make it face camera always, maybe. Well, actually, let's just leave it as that, and let's see what's gonna happen here. Alright, there we go. As you can see, that the part goes forward and backward, but it's still ahead of the part. Let's increase the frequency of the sine wave. Times, let's say 10, for example. See that? You see what's happening here? Let's do 20 seconds or something. Lifetime 20 seconds. Face camera, maybe. And I guess we're all good. See that? There we go, man. That's really nice. Alright, that should be it for now. If you want more tutorials about CFrames, let me know. This was just a basic tutorial to show you like a basic understanding and basic intuition of how you can use CFrames and how to approach them. So yeah, anyway, see you later guys. Goodbye.